Hey, ladies and gentlemen, this is Miss Hummert here, and today we're going to be doing Unit 7, Note 3. So we're going to be talking about the fundamental counting principle and how it applies to factorials, which is the new term we're going to be learning today. So let's kind of review what we've been doing with the fundamental counting principle so far, and then we're going to apply it to factorials. So how many ways can you arrange the word math? So previously, when we were arranging the word math, we said, okay, there's 4 letters, so I made 4 spots. So when I choose my first letter, I have 4 choices, and then I have 3, and then I have 2, and then I have 1. So you multiply all of those out, and you get 24 different ways that you can multiply each of those letters, or you can arrange each of those letters. Next, let's take a look at the next one. How many different ways can you arrange the word in Verizon if Z must be the first letter? Well, how many letters are in Verizon? We have 1, 2, 3, 4, 5, 6, 7 letters. So I have 1, 2, 3, 4, 5, 6, 7 blanks. But now we're saying, okay, this first blank has to be Z. And there's only one way that that first letter can be Z. So then, if there's 7 letters and the first one's Z, for my second, I only have 6 choices. And then I had 5, and then 4, and then 3, and then 2, and then 1. So that's being multiplied all the way down. 1 times 6 times 5 times 4 times 3 times 2 times 1. And then when you multiply all of that out, you end up getting 720 different ways that you can rearrange the letters in Verizon if the first one is a Z. We also did this on the first note video. We did something like this. You're picking out a new car for your birthday. You can choose between 6 exterior colors. So that means you have 6 choices for the exterior colors, 8 choices for the interior colors, and 5 fabric choices. So all you did was multiply 6 times 8 times 5. And when you did that, you got 240 ways for that one. All right, next, let's take a look at number 4. So for number 4, the student council has a president, vice president, treasurer, and secretary. For the school assembly, they're all required to sit up in row on the stage. How many different ways can they arrange themselves? Well, you have a president, vice president, treasurer, secretary. So there's 4 spots that are going to be up on stage. When you go to pick the first one, you're going to do a 4, and then a 3, and then a 2, and then a 1. So you're going to go ahead and multiply your way down. And then you get 24 different ways that you can arrange those officers up on stage. Now that we've talked about that, let's go ahead and take a look at what a factorial is. So when you see a factorial, it looks like a really happy, excited N. It's N exclamation point. So N exclamation point is what it looks like, but it's actually read N factorial. It's the product of all the positive integers beginning with N and counting backwards to 1. Now that's a whole lot of mumbo jumbo, but guess what? You did this on the last note sheet. So let's take a look at an example. So what is this factorial mean? So make sure you have that written down, please. So we have, what is 6 factorial? Well, 6 factorial, all we do to calculate out 6 factorial is do 6 times 5 times 4 times 3 times 2 times 1. Okay, that's all we have to do is 6 times 5 times 4 times 3 times 2 times 1. And you type that in your calculator and you get 720. Okay, so it's not a word problem, so our answer is just 720, because right now we're just calculating out the factorial. Same with 8 factorial. What's 8 factorial? Well, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you can go ahead and type all of that into your calculator. This is purely just about using the calculator. So you get 40,220 ways for that 8 factorial. Okay? All right, let's take a look at where we can apply some of these factorials. So, and that's one of those is if we're trying to find arrangements of words that have repeated letters. So the permutation of n objects where p and q are alike is, so p and q are letters that are repeating. So n factorial divided by p factorial, q factorial. So that looks really confusing, but it's actually not that bad when you take it and you apply it to an example with factorials. So let's go ahead and do that and make sure you have all that written down before you move on. So let's take a look at number 7. How many ways can the letters in geometry be arranged? So the first thing I'm going to do is count out how many letters I have in the word geometry. I have 1, 2, 3, 4, 5, 6, 7, 8 letters in the word geometry. So on the top of my fraction, I'm going to have 8 factorial. Then I need to divide by any letter that's repeating, and I need to divide by how many letters it's repeating by. So I see that E is repeated twice. So for e, I'm going to divide by 2 factorial. So let's go ahead and let's divide that out. So then I have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 factorial, which is 2 times 1. So what I'm going to do is I'm going to cross off my overlapping. So 2 and 1 are overlapping, so I'm going to get rid of them. So then to solve this problem, all I have to do is 8 times 7 times 6 times 5 times 4 times 3. And when you do that, you get 20,160 ways. Okay, so why do we have to divide when it's a repeating letter? Well, think about it. If we start with E, does it matter which E we start with? Well, no. So that's why we need to divide to account for the fact that that E could show up twice and it would still look the same. So that's why we divide. So let's take a look at an example that has 2 letters that are repeating. Or 3 letters, actually, okay? So let's take a look at the word Mississippi. So to start off with, we need to count how many letters there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 letters. So that's 11 factorial. And then we need to divide by anything that's repeating. So for the repeating, we have I, that is repeated 4 times. So I'm going to divide by 4 factorial first to account for the fact that that I is being repeated 4 times. Then I'm going to take a look at S. I have 1, 2, 3, 4 S's. So I'm going to divide by 4 factorial to account for those S's that are repeated 4 times. And then I have 2 P's. So then I'm going to divide also by 2 factorial to account for all of those that have been repeated. So let's go ahead and let's write this out. So I'm going to give myself some space. So I have 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then on the bottom, 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1 times 2 times 1 when you write out all of those factorials. So what I'm going to do is I'm going to cross off as much as I can that's easy. So I can cross off 4, 3, 2, 1 and 4, 3, 2, 1. Okay, so I at least got rid of some of it. So here's what I'm going to do next, because simplifying it isn't as obvious anymore. So what I'm going to do is I'm going to multiply 11 times 10 times 9 times 8 times 7 times 6 times 5. And when I multiply that out, I get 151,200 on top. And then I'm going to multiply out my bottom. 4 times 3 times 2 times 1 times 2 times 1 is 48. So then, in my calculator, notice how I took the step to actually multiply out the top and then actually multiply out the bottom. You need to multiply them out before you divide. So now I'm going to take 151,200 divided by 48. And when I do that, I get 3,150 ways that you can arrange the letters in Mississippi, which actually doesn't seem like that much considering it has 11 letters, but they're being repeated, and that's why. Okay, or does it have 10 letters? Did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Nope, it has 11. So this is actually needing to be multiplied by 11. So my top number is actually wrong. 9 times 8 times 7 times 6 times 5. Okay, so this number should have actually been this, because Miss Humbert can't count when she's making her key, apparently. So then let's go ahead and change this answer up a little bit. So then we're going to divide by 48. So hopefully that didn't confuse you too much. I thought there were 10 letters when there really were 11, so that should be your final answer instead. That was my bad, so hopefully you hung with me. Let's go ahead and let's take a look at this review. So I have 1/2 x is equal to 8. About 90% of you would tell me that x is equal to 4. Well, that's not true. 1/2 x is the same as x divided by 2. Well, what's the opposite of dividing? That's going to be multiplying. So you need to multiply both sides by 2. So you end up getting x is equal to 16, not x is equal to 4. Let's go ahead and solve this equation. Well, this 3 is going to be subtracted, so I need to add to both sides. So then I get 2x is equal to 15 plus 3, which is 18. And then I'm going to divide both sides by 2, and I get that x is equal to 9. So x is equal to 9. So that concludes your note video today. Go ahead and show me your completed note sheet when you're done. Thanks for listening.